Good day everyone. We have seen in the previous video of definite integrals a property, that is integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. We use this for integrating modulus functions. If we get two intervals, we will write it as a to c and c to b, and of course we can extend it if we get two or three more points like that. Now we will see a different sum in that. Now you have to find integral minus 1 to 2 f of x dx if your f of x consists of modulus x plus 1 plus modulus x plus modulus x minus 1. So in the f of x you have three different modulus functions. It will be very difficult and roundabout if you take each one as a separate sum and if you integrate taking two integrals. Instead I will teach you how to combine them as easily and then you can do it, right? So now, as you know, the modulus we have to interpret like this. Mod x plus 1 is equal to x plus 1 when your x is greater than or equal to minus 1. It is equal to minus of x plus 1 when x is lesser than or equal to minus 1. We can have the equality on both because it is a continuous integral, right? Then mod x will be equal to x when x is greater than or equal to 0. It is equal to minus x when x is lesser than or equal to 0. Mod x minus 1 is equal to x minus 1 when x greater than or equal to 1. It is equal to minus of x minus 1 when x is lesser than or equal to 1. All these things you have learnt in the previous videos. Now, once you find the interpretation for the three modulus, you know you have to draw a number line. Here our limits are minus 1 to 2. So that minus 1 is my a, the lower limit, and the upper limit, that is 2, that is b. Now in between, now we have got actually three values for x, minus 1, 0 and plus 1. The minus 1 already coincides with the a. So I have now two different values, that is 0 and 1. So now the minus 1 to 2, that interval has been divided into three sub-intervals, that is minus 1 to 0, 0 to 1, 1 to 2. So actually here instead of two integrals, now I will be getting three integrals. Let me write it how it will appear. That is my I, which is minus 1 to 2 f of x dx. I can write it as integral. The first one is minus 1 to 0 f of x dx plus the second one 0 to 1 f of x dx. Then for the third interval 1 to 2 f of x dx. But each f of x will differ. They are not same. We have to use these interpretations and let us find out what is the f of x for each interval and then we will do it, right? So now, first let us consider this first interval. That is, it is from minus 1 to 0. So I can write it as minus 1 less than or equal to x less than or equal to 0. This is my first interval. That means my x is greater than minus 1. My x is lesser than 0. It may be equal also. So now let me find out what is my f of x. I will combine these three, the values in this interval. If you consider the first one, that is mod x plus 1. Now see here, it is equal to the positive when it is greater than or equal to minus 1. It is lesser when it is lesser than or equal to minus 1. Now when you see it is greater than minus 1, so you will get that will be x plus 1. That is the first part is positive. Coming to the second one, mod x. When it is greater than 0, it is positive. When it is lesser than 0, it is negative. Now in this interval, it will be lesser than 0. So you will get a negation here. So that will be minus x. When you come to the third one, mod x minus 1, that will be greater if it is greater than 1. That will be lesser if it is lesser than 1. So naturally it is lesser. So you will get a minus of x minus 1. So actually what we have done in this interval, we take each of these modulus function and we write whether that will be positive or negative. Now let us combine the three. So now we will be getting 1x, x will get cancelled, right? So you will get 1 plus 1, 2, then 2 minus x. So let me write it. This is my 2 minus x. This is the f of x for this particular interval. Now let us move on to the second interval. The second interval is 0 less than or equal to x less than or equal to 1. This is my second interval. Now I am going to find out what is the f of x for that one. Now you know it is this interval. It is greater than 0 but less than 1. Now come to the first one. Definitely it is greater than minus 1 because it is greater than 0. So that is going to be positive for you. Coming to the second one, that is greater than 0. So that is also going to be positive for you now. But the third one, when only it is greater than 1, it will be positive. So now that will be negative for you. So you will get minus of x minus 1. So now 1 plus x and 1 minus x will go. You will get 2 plus x here. This is your f of x for the second interval. Then coming to the third interval, 1 less than or equal to x less than or equal to 2. Here let us calculate the f of x. Now you know it is greater than 1. For everything is going to be positive naturally. Okay. So now you will get that is equal to x plus 1 plus x minus 1. Now that plus 1 and minus 1 will go. So you will get here 3x. Do you understand this? Because this is the very important step in this one. You should find out the f of x for each interval using the interpretation of modulus, whether it is greater, whether it is less, whether it is positive or whether it is negative. Once you have found out this, now the sum becomes simple for you. Now you will get your I, that is I call this left hand side as I. That now becomes minus 1 to 0. I will write 2 minus x dx plus 0 to 1. I will get 2 plus x dx plus integral 1 to 2 3x dx. Hope this is clear to you. So first what have we done now? We wrote the interpretation of mod x, we wrote the intervals. So here we got 3 intervals. So in the each interval we found out what is the f of x. This is what we have to do first. Okay. Now in the first integral I am going to take one minus out so that I will get x minus 2 dx. That will be easy for me to integrate. So I am taking 1, this is minus 1, this is 0, x minus 2 dx. Here let me keep it as it is, 0 to 1, 2 plus x dx. Here I will take 3 out, 1 to 2, x dx, right? So now when I integrate this x minus 2, I can do it in 2 ways, you know. I can integrate them separately like x squared by 2 minus 2x, or I can take that x minus 2 as a whole. I can write x minus 2 the whole square by 2. That will be easy for me for the substitution of limits. So now I am going to write this as minus is out. I will be getting x minus 2 the whole square by 2 within the limits minus 1 to 0. Similarly for the second one I will be getting 2 plus x the whole square by 2 within the limits 0 to 1. 3 is 3 into x squared by 2 within the limits 1 to 2. So you have got just 3 simple integral sums. Now generally whenever you substitute the limits, it is better you avoid the fractions. No, you can take all the constants out and then if you substitute upper limit minus lower limit, that will be easy for you. So now here I am taking this 2 out. So I get minus 1 by 2. So I have x minus 2 the whole square. First the upper limit is 0. So I get minus 2 the whole square, which is 4. Then minus. The lower limit is minus 1. Minus 1 minus 2 is minus 3. Minus 3 the whole square will be 9. Right? Now here I take that 2 in the denominator out. So I get 2 plus x the whole square. The upper limit is 1. 1 plus 2 is 3. 3 square is 9 minus the lower limit is 0. So 2 square is 4. Right? Now take the 2 in the denominator out. I get 3 by 2. X squared will be 2 squared is 4 minus 1 squared is 1. So you have made it simpler. No? When we take the constants out, the calculations will be easier for you. So here what do I get? Here minus 5. Here is 1 minus. So I get a 5 by 2. Again I get a 5 by 2. Here I will get 9 by 2. So now just add the numerators. The denominator is 2. So you get 19 by 2. That is the answer for this. So now in this sum, what are all the things you have to remember? Let me tell you once again. First, whatever modulus functions are given, 3 or 4, write the interpretation where it will be positive, where it will be negative, and what is the x values like that. Then you have a number line. Write the lower limit and upper limit given in the sum as that a and b. In between, check how many values you give. Write them here. Here, because I get 2 values, I get 3 intervals. If you get 3 values, you will get 4 intervals. If you get 1 value, you will get 2 intervals. Okay. Then find the f of x in each interval for all the modulus and combine them. Then you can split them into either 2 or 3 depending upon what you get, and then it is like each sum you have to take separately and then you have to calculate. Whenever you calculate, substitute the limits, take the constants out so that the calculations become easy. Otherwise it will become a bit cumbersome. Okay. Hope you have understood this. Thanks for watching the video. You can subscribe and you can click the bell icon so that you will get notifications of further videos. Thank you once again.